welcome to the IMS Gate Academy. How are you all? Okay, so please confirm audio video if both are clear or not. Okay, so hoping that everything is good, that the audio and video, so that we can start with the with the session, that is the lecture number 6. Okay, so as you know that this is a foundation course of the electrical machine, in which total of 5 lecture was already happened. So those who have Mathan, good evening Mathan, please confirm audio video Mathan. So those who have not watched those particular 5 lectures, so please, once the session is going to be ended, please go watch those particular session as well. Definitely you will going to, okay, thank you Mathan. So you will definitely will going to enjoy those particular session. And since this is a foundation course, or you can say the building of the particular subject which is here electrical machine, the advantage you can taking forward not only in the GATE exam, also in your BE and BTech. So this is very important for you, as you know that the electrical machine, one of the used subject, and you can say was subject, and sometimes the students, for the students it is nightmare subject. So yeah, irrespective of all those things, if you going to study in a much better manner, like from me, definitely you will going to enjoy this subject and you will feel this subject to be very easy. Okay, this is my assurity to you. Alright, so guys, one request, please share the session link with your friend so that they can also join as quickly as possible, and definitely we will going to see a wonderful and challenging session and the most interactive session over the YouTube platform. Okay, and also if you are new to our YouTube channel, then you can subscribe to our YouTube channel. At the same time, please press the bell icon, because I want you to be the first one to get notified for all the session that we are coming up live over our YouTube channel. Okay, so this is going to be the lecture number 6, in which I will going to discuss the force on conductor. And yes, it is very important, because this is not limited to transformer, not limited to DC, not limited to synchronous or induction. It is applicable for all the machines. Okay, if you're going to study this particular chapter, then my dear friend, the concept you can also going to be used in the EMFT. So basically there is a linear relation, you can say. If you know the EMFT very well, then you can easily understand this particular topic, or if you understand this particular topic here, then you can take the advantage of the concept that we will going to discuss over here in the EMFT. ठीक है? So कुछ भी doubt होगा, please do post in the chat box. I'll be very happy to clear all of your doubt. Okay, so let us start with the lecture number 6, that is force on the conductor. Okay, so under this, the first one is the Lorentz law. Okay, so Lorentz law. So what do you mean by this? What Lorentz says? It says that whenever a charge, or sorry, whenever a conductor is placed in a magnetic field, then it experiences a force, provided the conductor is moving in a magnetic field. Am I clear? So see what it tells. It says F equal to, just a second. What it says F, this is equal to charge velocity of a conductor into the conductor in which the magnetic field where the conductor is moving. So F equal to Q times of V cross B. Now as you see here, this is a magnetic field, so this is a force due to magnetic field. This is a force due to a magnetic field. All right. So now we know that the force can not only generated by the magnetic field, it can also generated by the electric field. If a charge or a conductor is placed in a in an electric field, then also it is going to experience as a force. So let me take here FB because the magnetic field, and FE under the presence of electric field, which is equal to Q times of E, where E is the electric field. All right. So this is force due to in the electric field. Force in an electric field. Okay, so what I can conclude? I can conclude that the total force on a charge, that is Ft, this is equal to Q V cross B, V cross B plus Q times of E. So this is a vector basically. Any doubt till here? So I can write this as Q times, let me take Q common. So this will be equal to V cross B, V cross B plus E. So this is the total force under the presence of magnetic field as well as under the presence of electric field. Okay, so the first portion, the first formula is due to the Lorentz, but if you go by the electric field and the magnetic field, the force that it will going to give is this one. Okay. Chalo. So see here, this is a magnetic field. This is a magnetic field. Let me place a conductor. Let me just a second. Okay, suppose this is the conductor which is placed in a magnetic field, and this conductor is moving in right direction with a velocity v. I hope this is clear. Okay. This is moving with a velocity v in a right direction. So it will going to experience a force, and that force direction is given by Fleming left hand rule. Am I clear? But in the first chapter we had discussed about how we can find the force on a particular conductor under the presence of magnetic field by using a simple shortcut, what to say, the shortcut way. How? See, point your, like, stretch your right hand and point your 4 fingers in the direction of velocity of a conductor, because it is V cross B. See here, V cross B under the presence of magnetic field. So V cross B placed under the direction of magnetic field, under the in the direction of velocity of a conductor, which is here. And this magnetic field is inside because you are seeing the cross. So cross means it is into the board. Dot means it is outside of the board. So point your 4 finger in the direction of velocity of the conductor, and magnetic field is inside. Okay, magnetic field is inside. It means that the force it is going to be have in what direction? In which direction it will going to have the force? V and point in the magnetic field direction, which is inside. So it is upward. So let me change the color. Okay, where it gone? Okay, so this is a force direction, which is upward. Force due to magnetic field. Okay, let us move ahead. Now let us come to the force on a current carrying conductor. So what do you mean by this? As we had already discussed in the lecture number 1, that whenever a current is flowing in a conductor, and if that conductor is placed in a magnetic field, then it will going to experience as a force, as we had discussed over here. ठीक है? So let me take a magnetic field like this. Okay, just a second. Let me take a magnetic field like this. Just a second. Let me make it this diagram. Please wait for that. Let me make a diagram. So magnetic field का direction क्या है? What is the direction of magnetic field? It is inside of the board. So this is magnetic field. Okay. So let me take B. This is B. Now let us place a conductor in the magnetic field. Okay, sorry. So this is a conductor which is placed in a magnetic field. Okay, done. Now assuming that your conductor is moving. Now assuming that your conductor is moving. So whenever a conductor is moving, and if the charge inside that is also moving, then your force F will be equal to what? See here, or let me say del F, sorry, F. This is equal to Q times of Vd cross B. So what do you mean by Vd? Vd is the drift velocity. This Vd is the drift velocity. So what do you mean by this? Whenever a charge is flowing inside the conductor, whenever a charge is flowing inside a conductor, then the velocity of the charge is known as drift velocity, which is this one. Okay. Now let me take a small length. Instead of the complete, let me take a small length of a conductor. Let me take this length. Which is DL length. This length is DL. Okay, ये clear है? So instead of complete length, I have taken here del L just to see what will be the force it will going to be have in this particular length of a conductor, and after that to find the complete force or the overall force, I will going to integrate over the entire length. वही तो करते हो ना इंटीग्रेशन में. आप छोटा सा पार्ट लेते हो, then assuming that the छोटा part will have a del F force, so हर एक part पे निकालो, then add up, which is nothing but the integration. Am I clear? So what it means? It means that del F due to small length will be equal to Q times of del L by del T into magnetic field. है ना? because this is a velocity. So what is changing? The length is going to be changed over the period of time. So del F, okay, del F will be, okay, ye del Q, because of the small charge. I am not taking the complete charge because this, like see, assuming that the entire length will have a Q charge, then a small length del L will have a charge del Q. So del Q I have written over here. So take out dt outside. So dq by dt into del L into B. And what is dq by dt? This is current I, and del L cross B. So I can write this as I dl cross B, because the current which is flowing here, let me take I current is flowing inside this conductor. So whether you take a small length of this particular conductor or entire length, everywhere what is the current? Current will be I. So this is your force equation, this is your force equation when a current carrying conductor is placed under the magnetic field. So how to find its direction? How to find the direction over here from IDL cross B? Very simple. Again, use your right hand, point your forefinger in the direction of ideal. See, in the direction of ideal, because the first term is what? Ideal. So ideal is upward. And where is magnetic field? Magnetic field is inside. So curl your forefinger in the direction of magnetic field. First ideal, then inside. It means that the force is upward. So here the force is okay. So the force here is del F. Okay, del F. Just a second. Let me have some space over here. This del F is nothing but I dl cross B. Any doubt, my friend? Any doubt? Clear hai? So this is what we are having the force on a current carrying conductor. So please do remember this. This is a force under the presence of magnetic field when conductor is moving, and when a same conductor is carrying a current I. When a same conductor is carrying a current I, then it will going to have the force like this. Chalo. Now let us discuss the force on a conductor carrying a current in the same direction. So what do you mean by this? Suppose you have a conductor. Suppose you have a two conductor, and in both the conductor current is flowing. So the current can flow in two manner. In both the conductor, either the current is flowing in the same direction or in opposite direction. So we will going to take both case over here. Clear hai? So how to find the force on a conductor which is carrying a current in the same direction? So let me assume that your conductor length is infinite. ठीक है, वो infinite length का conductor है, and in that the current is coming outward of the board. Coming outward of the board. It means that you will going to see a point. देखो अगर ये current आपकी ओर आ रहा है, so you will see the tip ना, or the front part. So it will be what? A kind of point. If you compare this with arrow, जो धनुष बाण जो होता है ना, तो वो जो arrow जो उसमें होती है, so that arrow we will going to see a tip. So it will be dot. So let me take a two conductor of infinite length. Okay, just a second. ठीक है. Okay, so as I told you, we will going to assume the current in a conductor 1 as I1, means in this conductor current I1 is flowing, and in conductor 2, let me take I2 current is flowing, but the direction is same because these two conductors, see this two conductor is placed in horizontal manner like this, and the length of this conductor is infinite, and the current is coming towards you. Now we know that whenever a current is flowing in a conductor, it will going to generate a magnetic field, or it will going to produce a magnetic field, and the direction is given by Fleming right hand palm rule that we had discussed in the lecture 1. So see, the current is outward, है ना? It means that this forefinger is curled around the direction of magnetic field. So here the direction of magnetic field for the first conductor, or let me change the color for this. Okay. ये visible है क्या ये color? So this is I2. Okay, so for the first one, as we have discussed, that the direction here is clockwise, sorry, the anti-clockwise. Okay. So this is B1, magnetic field direction. Okay. Let me tell you one more time, Fleming right hand palm rule. So outward, then this is your magnetic field direction. Similarly, let me change the color. So the current here is I2, and again what is the direction? Everybody see, outward, then it will curl in anti-clockwise direction. So for this conductor, the direction of magnetic field will be like this, which is B2. Okay, great. Now if you observe the particular direction carefully, if you observe the particular direction carefully, you will see that in the conductor 2, the direction for the magnetic field in the conductor 2, it is upward. यहाँ पे देखो ये upward जा रहा है ना. So what is the direction over here? It will be upward. So direction is B1. कोई डाउट यहाँ पे? देखो यहाँ पे क्या हो रहा है, अपवर्ड जा रहा है ना. So this is reason why I have made here upward direction. And in this conductor, see what is the direction of the B2 in this conductor? It is downward. See the arrow, it is downward. So this conductor will have the arrow in downward. Please feel free to ask any doubt. So this is B2. Okay, am I clear? Am I clear? Then the force onto due to 1 is F12. F12. So the force on 2 due to 1 is F12. Similarly, the force on 1 due to 2, so it will be F21. Okay. Now, sorry. Now, what is this F21 or F12? Let me write F21 first. F12 first. Now, we know that this current is, this conductor is carrying a current, or let me take here, this conductor is carrying a current, and this conductor is under the presence of magnetic field, which is B1, Therefore, it will going to experience a force. So, F12 is what? Nothing but I2 del L2. Let me take del L2 into B1. Any doubt? Clear? Okay. Now, let me take a distance between a center to center. This distance from center to center, let me take. This distance is D. This distance is D. Now, my dear friend, let me take equation 1. See, F12, the force direction, how we can get? I2 dl2. So, this is I2 and current is outward. So, it is towards U. है ना? It is towards U. And where is B1? B1 is upward. So, कैसे होगा? I2 dl2 is towards U and B1 is upward. So, the force is towards left hand side. So, here the force is, towards left hand side. And similarly, F21 कैसे होगा? See, F21 will be equal to I1 del L1 into magnetic field B2. Let me take equation 2. So, कहाँ गया? Yeah, I1 del L1. So, it is outside. And B1 is what? And B2 na? B2 is downward. So, curl your forefinger in B2 direction. So, like this. So, F21 is in which direction? F21 is in this direction. So, therefore, I can say that the force between both the conductor, hence force between both conductor is attractive or repulsive. See, the force is what? Towards each other, na? It means that the force between both the conductor is attractive. Attractive in nature. Now, we have found the direction or a repulsion or attractive. But what will be the magnitude? For that, we will going to use equation 1 and equation 2 thereafter. So, let me take equation 1 from equation 1. चलो, क्या है? Equation 1, F12, this is equal to I2 del L2 into B1 vector. Okay. So, for this see, you are having the I2 del L2, so means it is a vector. So, it will going to have magnitude and direction. So, for that, let me take the help of x, y, z coordinate. Okay. Let me take the help of x, y, z coordinate. Okay. Just a second. Let me change the color. Okay. Let me make here x, y, z coordinate. So, this is x, this is y, this is x, y and z. Okay, great. ठीक है. So see, I2 del L2 in which direction? It is towards us, so it will be x. So ये कैसे होगा? I2 del L2, this is magnitude, and what is the direction? Ax cap into B1 का डायरेक्शन क्या है? B1 is upward, so it is following Z direction ना. So magnitude of B1 is B1 and direction is AZ cap. So let me take the together I2 del L2 B1. So this is magnitude and AX cross AZ cap. Now B1 is equal to mu naught I2 del L2. See, B1, the magnetic field of B1 at this center or at a distance d from here, at a distance d, it will be equal to mu naught H1. It will be equal to mu naught H1, and H1 is I1 divided by 2 pi d. क्या ये समझ में आया सबको? मैंने क्या क्या यहाँ पे? Here I have substituted the value of B1 from the Biot-Savart's law, B1. So whenever a conductor is of infinite length and current is flowing in that conductor, then let me change the color. Then we can directly write B1 equal to mu naught H1, and H1 is equal to mu naught. What is the current in the conductor 1? I1 divided by 2 pi. At what distance from the center we are getting this H1? At this distance, so which is having the value as d. ठीक है, कोई डाउट यहाँ तक? Is it clear everything? Is it clear everybody? Now AX cross AZ क्या होगा? We will going to use the Cartesian rule. AX cross AY will be AZ. Then AX cross AZ in anti-clockwise direction, so it will be taken as negative. For clockwise it will be positive. So AX cross AZ will be minus AY. तो ये वैल्यू क्या होगा? It is going to be minus AY. So minus AY के. Now from here we can also find that F12 will have this magnitude and direction is minus AY. Minus AY means Ajay, good evening Ajay, you are late. Why? So minus AY is here ना, देखो ये प्लेन y इस डायरेक्शन में है तो माइनस y इस डायरेक्शन में होगा, और वही हमने फाइंड किया था. ओके, सो आई कैन से दैट F12 this is equal to mu naught I1 I2 upon 2 pi d, mu naught I1 I2 upon 2 pi d del L2, and direction is minus AY cap. So therefore force per unit length F12 divided by del L means force per unit length, sorry, this will be equal to what? The magnitude mu naught I1 I2 upon 2 pi d, and its direction is minus AY. Am I clear? Any doubt? So let me inbox this. Okay. So similarly F21 ये क्या होगा जल्दी से बताएं. here the current element is what? I2, sorry, I1 del L1, and what is the magnetic field in this? It will be downward, so which is B2. We have a question. So ट्रांसफार्मर कोर पर वाइंडिंग लगाते समय पहले कोर पर इंसुलेशन क्या लिखे हो समझ में? वेफर लिखे हो क्या? लगाते हैं या बिना इंसुलेशन के? अरे नहीं, इंसुलेशन विल बी गिवन फॉर इन द व्हाट टू से योर वायर, बिकॉज अगर आप इंसुलेशन नहीं दोगे और राउंड अप कर दोगे तो वो शॉर्ट हो जाएगा ना. So we will have to provide the insulation such that the other segment of the same copper wire should not be touched, otherwise it will going to be short circuit. इसलिए एक पतली लेयर जो हम बिछाते हैं ताकि वो डायरेक्ट कांटेक्ट में ना आए एक दूसरे के. ठीक है, बाय द वे गुड क्वेश्चन अजय. सो सी हियर, दिस इज I1 del L1. सो इसका मैग्नीट्यूड क्या होगा? I1 del L1, दिस इज मैग्नीट्यूड. और इसका डायरेक्शन क्या होगा? इट इज आउटसाइड ना, आउटसाइड मतलब कि AX एंड B2 का मैग्नीट्यूड इज B2 एंड इसका डायरेक्शन क्या होगा? सी, B2 इज डाउनवर्ड, सो इट इज फॉलोइंग माइनस AZ डायरेक्शन, मीन्स माइनस AZ. तो ये क्या हो जाएगा? दिस विल बी I1 del L1 इंटू B2. सो B2 आई कैन राइट म्यू नॉट H2. सो DL वेक्टर की डायरेक्शन कैसे डिसाइड करते हैं? DL नहीं, जैसे आपने कंडक्टर को प्लेस किया हुआ है ना, जैसे समझ लो आपने ये स्ट्रेट और इस वर्टिकल डायरेक्शन में किया है, तो इसकी डायरेक्शन क्या हो जाएगी DL की? इट विल बी इन Z डायरेक्शन. अगर आप ऐसे रख दोगे तो DL डायरेक्शन क्या हो जाएगा? X का डायरेक्शन. ठीक है, क्लियर है? सो इट इज नथिंग बट the direction for DL is nothing but how your conductor is placed in that particular direction. It will going to be defined. Okay, so see here, so this B2 is nothing but mu naught H2, and we have discussed na, H2 is I2 upon 2 pi D, and AX cross माइनस AZ कैप. सो ये क्या हो जाएगा? सी हियर, ये क्या हो जाएगा? F21, दिस विल बी इक्वल टू म्यू नॉट I1 I2 म्यू नॉट I1 I2 2 pi D डिवाइडेड बाई 2 pi D. और लेट मी टेक डायरेक्टली पर यूनिट लेंथ. मैं डायरेक्टली लिख दे रहा हूं पर यूनिट लेंथ ना. डेल L1, लास्ट में क्या लिखा? डेल L2. हाँ, सीख. सो दिस इज इक्वल टू म्यू नॉट I1 I2 अपॉन 2 pi D. एंड व्हाट इज द डायरेक्शन? सी, AX क्रॉस माइनस AZ. आई कैन राइट लाइक दिस, AX into AZ. This and this both are same. So AX cross AZ is what? Minus AY, and you are having one more negative sign. So it makes plus AY. So plus AY direction. ठीक है? So AY की डायरेक्शन क्या है? इस साइड, टुवर्ड्स राइट हैंड साइड. सो देखो, इसलिए मैंने F21 यहां से भी दिखाया. So yeah, it is clear that whatever direction we have got from the formula, it is syncing with the thing that we have obtained. But my dear friend, we are talking about the magnitude. So see here, the magnitude of F12, that is per unit length del L2, is equal to magnitude. I am talking about magnitude is equal to F21 divided by del L1. So hence the magnitude is same, but direction we can find from the Fleming left hand rule. Okay, Ajay, सर कोर पे इंसुलेशन लगाते हैं कि इंसुलेटिंग वायर होती है, कोर पर नहीं लगाते। क्वेश्चन क्लियर नहीं हो पा रहा है। सर कोर पे इंसुलेशन लगाते हैं कि इंसुलेटिंग वायर, नहीं इंसुलेशन लगाते मतलब अगर जैसे मैं ट्रांसफॉर्मर की बात कर रहा हूँ ना, तो ट्रांसफॉर्मर एक सिंगल कोर नहीं होता है, इट इज अ लेयर ऑफ अ सिंगल कोर। सो जैसे मान लो ये सपोज मान लो ये एक शीट है, ओके, दिस इज अ कोर एंड आफ्टर दिस यू विल गोइंग टू हैव अ insulation, then after that you are going to have a core, iron core, then insulation, then iron core, such that the eddy current should not pass through this particular core, इसीलिए उसको insulation लगाते हैं। बट जो मैं वाइंडिंग की बात कर रहा था ना, you know ना, in a transformer you are having primary and secondary winding, so in the primary side you will be having a primary coil, so हर coil पे क्या होगा, एक insulating layer हम चढ़ाते हैं ताकि वो डायरेक्टली कोर के कांटेक्ट में ना आ जाए, बिकॉज it will make the core to be, or basically it will hamper the coil, or in sometimes it may destroy the core। ठीक है, क्योंकि कोर पे क्या होता है, करंट भी फ्लो डेफिनेटली कर सकता है ना, वो आयरन है, तो डेफिनेटली द करंट कैन फ्लो, तो उसको बचाने के लिए वी इंसुलेट द वाइंडिंग, और इंसुलेशन कहां पे लगाते हैं, बिटवीन द कोर्स। क्लियर है अजय? चलो, नाउ कम टू द नेक्स्ट पार्ट, दैट इज फोर्स ऑन अ कंडक्टर कैरिंग अ करंट इन अपोजिट डायरेक्शन। सो लेट मी टेक अ कंडक्टर लाइक दिस, ओके, one conductor and second conductor, but this time let me make this current as cross and this as dot. So here the current is, let me take I1, and here the current is I2. Okay, so what is the magnetic field? Since this time the current is inward na, so it is clockwise direction. So यहाँ पे magnetic field is what? Sorry, it is clockwise. This time it is clockwise. So this is B1, और इसका क्या होगा, इसका it will be, see it is outside, so it will be anti-clockwise. So this is B2. Okay, now let us find the force. देखो यहाँ पे force कैसे लगेगा, in this conductor the current the magnetic field direction of B1 will be what? देखो यहाँ पे क्या जा रहा है, डाउनवर्ड जा रहा है ना, so it will be downward, B1 का डायरेक्शन डाउनवर्ड, and similarly in this conductor, that is conductor 1, B2 direction is downward. So here this is B1 direction, and here it is B2 direction. Okay, now Fleming right hand rule, the Fleming left hand rule, or simply we can use a shortcut. See, I2 DL2, basically let me take the force here, let me take a force here F12, that is force on conductor 2 due to 1. Let me take here force F21, force on conductor 1 due to 2. तो कैसे फाइंड करेंगे, as we had discussed already. See, I2 del L2 or F12, let me write the formula first. I2, okay, so F12, this is equal to I2 del L2 into magnetic field here is what? B1. Okay, so I2 del L2 is outside. Point your this forefinger in a direction of magnetic field which is downward. B1 downward है ना? So F12 is which side? It will be towards right hand side. So इसकी डायरेक्शन क्या हो गई? ये हो गई इसकी डायरेक्शन. डन. अब F12 की डायरेक्शन बताओ by using the same concept. See, I1 del L1 means F21. Let me write here this as equation 1. So F21, this will be I1 del L1 into B2. So I1 del L1 is inside and point in the magnetic field direction which is downward. B2 का डायरेक्शन देखेंगे downward. So F21 is in left hand side. So your direction is like this. So what we can conclude? What we can conclude? We can conclude that force is repulsive in nature. Therefore we can say that when a current is flowing in same direction, when a current is flowing in a same direction, then it will going to have the force of attraction. When current is flowing in opposite direction, then it will going to have the repulsive force. ठीक है? चलो, let us find the magnitude. So from equation 1, okay, so F12, this is equal to I2 del L2 into B1. Okay, so find the magnitude and direction of I2 del L2. Magnitude is I2 del L2, and what is the direction? It is outside, means AX cap, into magnitude of B1 is B1, and what is the direction of B1 here? It is downward. So can I say minus AZ cap? देखा था ना ये डायरेक्शन X, Y, Z. So B1 is in downward, so minus AZ, and this I2 del L2 is outside. It means in X direction. Clear है? कोई doubt? अजय, मथन, कोई doubt? Okay, so this F12 is equal to I2 del L2. Again, B1 is what? Mu naught H1. It is mu naught H1, and H1 is I1 upon 2 pi d. Means magnetic field intensity at this point. At this point. So this distance is d. And AX cross minus AZ. AX cross minus AZ. It will be AY. वही तो हमने फाइंड किया ना F12 की डायरेक्शन AY पे. ठीक है? Okay. Now from equation 2, क्या था equation 2? F21, this is equal to I1 del L1 into B2 vector. So take its magnitude and find its direction. So I1 del L1 and इसका डायरेक्शन क्या है? See, it is inside. So can I say minus ax के डायरेक्शन में होगा? So it will be minus ax cap into b2 का क्या होगा? Magnitude b2 and b2 is again downward. In this conductor, what is b2 direction? It is downward. So minus az cap. So this is equal to I1 del L1. Okay, and again b2 is what? Mu naught h2. Mu naught h2 is I2 upon 2 pi d, and minus ax minus az will be ax cross az, which is nothing but minus ay cap. Minus ay cap. So yes, it is clear that minus ay means in which direction? Towards left hand side. वही तो आ रहा था, towards left hand side. Okay. So हाँ, यहाँ पे first let us find the force per unit length कितना आ रहा है? Force per unit length. So यहीं पे find out कर लेते हैं F1 और simplify कर लेते हैं F1 del L2, this is equal to mu naught I1 I2 upon 2 pi d into ay cap. And similarly, in this case, F21 per unit length del L1, this is equal to mu naught I1 I2 upon 2 pi d minus ay cap. Minus ay cap. So क्या मैं बोल सकता हूं यहाँ पे, therefore F21 divided by del L2, sorry del L1 not L2, del L1 magnitude will be same F12 del L2. The magnitude will be same. But what about the direction? Force direction F21 is opposite of minus F12. So these 2 points are very, very important. Okay. So when they are in same direction, when the current is in same direction, so their magnitudes are equal, and at the same time F21 was equal to F12. This is what we have obtained, है ना? When current are in same direction. But when the current are in opposite direction, their magnitude will be same, but they are having the force of repulsive. So negative sign क्या बता रहा है? Force of repulsion. ठीक है? Any doubt? Any doubt till this point? Clear है? Now let us discuss one git problem, one simple problem, and after that we will close this particular session. Okay. See here, determine the magnitude of force and its direction. Assume B to be 0.50 Tesla, I, that is from top to bottom, the current direction is downward, which is 5 ampere, and the length of the conductor is 1 meter. बताएं क्या होगा? Do it fast. We know na F, this is equal to IDL cross B. Let me make an axis over here, X, Y, Z. Okay. सो आइडियल का मैग्नीट्यूड क्या होगा? सी, आई वैल्यू इज 5 एम्पेयर into what is the length of the conductor, complete length or entire length? It is 1. So 5 into 1. So this is ideal. But इसका डायरेक्शन क्या है? Top to bottom means it is following z minus z direction, which is downward. So it is minus az direction. Cross. B, what its magnitude? It is 0.5. And magnetic field का direction is what? See, this dot is what? Magnetic field. This is a magnetic field and conductor is placed inside the magnetic field. Dot, what it implies? Outward. Dot implies outward, है ना? So outward means ax के direction में. So I can say that 5 into 1, 5 into 0.5. So it is 2.5 minus az cap into ax Newton. Okay. So this is magnitude and this will going to give you the direction. So direction कैसे होगा? Direction कैसे होगा? See, az cross ax क्या होगा? This I can write in this manner. This I can write like this. Minus 2.5 az cross ax cap. So first point your forefinger in the z direction and curl in x direction like this. So it will be towards y direction. So it will be ay. But because of this negative sign, I can say that it will be 2.5 minus ay cap. Sorry, plus ay. Okay, this is plus ay, but this negative sign will make you minus ay. कोई doubt? Any doubt till this point? So minus ay किस डायरेक्शन में हो गया? इस डायरेक्शन में. So the force will be am I clear? So this is 2.5 minus ay. So this is magnitude and direction is minus ay, means towards this side. Towards this side. So this is force direction F. ठीक है, towards minus ay. You can simply use your right hand to find the force direction. Point your forefinger in the direction of ideal. So it is downward. So like this, ideal is downward, and point this forefinger towards the direction of magnetic field, or curl your ideal in the direction of magnetic field which is outward. So outward मतलब आपकी ओर, like this. So again the thumb shows the direction of force which is again at minus ay direction. ठीक है. So in this way you can find this 2.5 is magnitude and minus ay is the direction. Okay. So I hope all the concept is clear to you. So guys, if you have enjoyed the session, then please do hit the like button, and also please share the session link with your friend so that they can also going to get the benefit out of this particular session. And if you are new to our channel, then please do subscribe it, because it is very important for you, and also press the bell icon. The reason being, we are coming up live with more number of initiatives. So I want you to be the first one to get notified for those particular session or for all the session. Okay, so we have completed total 6 lecture. So from the next week, that is on like Thursday and Friday, so we will going to take the lecture 7 and lecture 8. The timing will be same, 4 to 5, and in that we will going to discuss a lot of thing again related to the foundations of the electrical machine. So guys, we have a Telegram channel. So if you wish to join our Telegram channel, the link is already given in the description box. So please do click that particular link, and after that you will be able to join the Telegram group. So what are the advantages you are going to get? The PDF, that whatever session that we have taken over here, the PDF you will going to find in the Telegram group. The update on webinar, seminar, the most important is what? Daily quizzes. So there you can practice a lot of quizzes that we are posting in the Telegram channel, and from there you can you can enhance your performance basically on a daily basis. And definitely, my friend, if you attempt all the quizzes, definitely you will going to see a drastic change in yourself. Okay, but for that you will have to attend the lecture in a live manner, and also after the lecture please do attempt all the quizzes. Okay, so we will meet you again on our next week. So bye bye, and take a very good care of your health.